Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video, Distance and Midpoint Formulas, is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. In this video, we will be reviewing the Cartesian coordinate system, discussing the distance formula and the midpoint formula. The distance and midpoint formulas derive from the Cartesian coordinate system. The x-axis, or the horizontal axis, and the y-axis, or the vertical axis, intersects at the origin 0, 0. Points of the coordinate plane may be plotted by their positions relative to the two axes, x and y. For example, 2, 1 is x equals 2 and y equals 1. Similarly with negative 1, 1, 1, negative 2, and negative 1, negative 3. The distance between 2 points when only one axis changes, for example, both points lie on the same y value of 2. In this case, the distance can be counted as 3, or 1 minus negative 2, which is the distance of 3. In another example, 2 points lie on the same x value. The distance can be counted, or simply subtract one y value from the other. 0 minus negative 2 equals 2. When the 2 points represent changes in both the x and y axes, we must take both into account. In this case, the distance between 2 points can be derived from the Pythagorean theorem, which is a squared plus b squared equals c squared, where a and b are the lengths of the two sides of the right triangle, and c is the length of the hypotenuse. When we apply this equation to the Cartesian grid, a and b represent the x and y components, and c is the distance between the 2 points. We can then simplify the equation to c is equal to the square root of a squared plus b squared. On our grid, let's establish one of the points as x1, y1, and the other as x2, y2. We can then label the point of the right angle x1, y2. We can now express as a distance a between the two x values, or x2 minus x1, and the distance b, in this case, can be expressed as the distance between the y values, or y2 minus y1. We apply this to our equation to get the distance formula. Next, we insert the values for our x's and y's and simplify. 2 minus negative 2 is 4, and negative 1 minus 2 is negative 3. 4 squared is 16, negative 3 squared is 9, 16 plus 9 is 25, and the square root of 25 is 5. Therefore, the distance of c is 5 units of measure. For example, let's find the distance between the points 1, 2, and negative 2, negative 3. We can plot the 2 points on our Cartesian coordinate grid, then establish one of the points as x1, y1, and the other as x2, y2. Remember from previous that the distance formula is c is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Next, we replace the terms with our established points and simplify. Negative 2 minus 1 equals negative 3, and negative 3 minus 2 equals negative 5. Negative 3 squared is 9, negative 5 squared is 25. 9 plus 25 equals 34. Our final answer then is the square root of 34, or approximately 5.83 units of measure. Let xy be the midpoint of the line segment x1, y1, x2, y2. By using the x and y elements of the line segment, we can create two triangles. By definition, the two sides x2, y2 to xy and xy to x1, y1 are of equal length. Also, the two angles connecting the line segments with the x and y components must also be equal. This makes the two triangles congruent by angle side angle. From this, we can establish the sides of the triangles as y2 minus y, y minus y1, x2 minus x, and x minus x1. This means x minus x1 is equal to x2 minus x, and y minus y1 is equal to y2 minus y. Add x1 and x to both sides of the equation to get 2x equals x2 plus x1, and likewise add y and y1 to both sides to get 2y equals y2 plus y1. Divide both sides by 2 to get x equals x2 plus x1 over 2, and y equals y2 plus y1 over 2. These two equations are used to find the midpoint xy between any two established points on our Cartesian coordinate grid. For example, find the midpoint between -2, 2 and 1, -3. We start with the midpoint equations, then establish -2, 2 as x1, y1, and 1, -3 as x2, y2, and fill in the equations with the appropriate numbers. 1 plus -2 over 2 is -1/2. -3 plus 2 over 2 is -1/2. Therefore, the midpoint is -1/2, -1/2. Given the endpoint of a line segment -2, -2, and the midpoint 0, -1, find the other endpoint. We'll first graph the two given points, then start with the midpoint formula. Next, we establish -2, -2 as x1, y1, and the midpoint 0, -1 as xy. Fill in the values in our equation and solve for x2, y2. x2 plus -2 over 2 equals 0, so x2 is 2. y2 plus -2 over 2 equals -1, or y2 equals 0. This makes the other endpoint 2, 0. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.